820 they slotted. If you want to find that node or zoom to that node means you just control F, you give control F.
Okay.
820, that node number you have to enter.
1 minute.
Okay, no problem.
For home, for first node, control home.
Yeah. You want to go to first node, control home. Last node, control end. You just write it down because after that you will forget.
Yes, that's what
And if you want to find anything, control F.
control F.
Yeah, control F. And enter that node number. And you take this zoom to node found, if found. Okay means it will go to the first node. Okay, first node they are modeled on equipment, I think so. Not compressor. Compressor will not be like this.
Yes.
Compressor.
Can you zoom out once?
That is some vessel.
Yes.
You see here anchor on anchor point. Up to the anchor point they model. But I don't know this is completely wrong. Okay, they have modeled the fixed saddle. Okay, it is okay.
Okay,
Up to the, yes. But you should not start. You should not start from the vessel. That's what. Okay, I have one ISO.
Okay.
Just a minute. I have one isometric. Can check. You see, this is one ISO. You see this from here. I marked a 510, no?
Yes.
510
Yes.
in the circle, inside the circle 510. That is the first node number, and it is connected to one equipment.
Okay.
That equipment is 1160 anchor point.
Okay.
We'll do this one because it will be easy for understanding.
Yes.
After getting some knowledge, if you go to that model, we'll see. Okay, first we'll model these things and we'll do that one later. Okay, first this is connected to equipment. This one.
Okay.
This is connected to the nozzle, and this 1160. No, that is on the surface of the equipment. That weld point.
Okay.
Nozzle is welded. No, that point.
Oh yes.
I'll show that equipment drawing also. This nozzle C. You see 63E001A, that is the equipment number, and C is the.
This is from PDMS.
No, that is from PDS.
PDS?
PDS.
From PDS.
Yes. This C nozzle, no?
Okay.
You see, can you able to see this one?
Yes.
This C nozzle is, this point only they marked as 500 something. This node number, no? This one only they marked as 500.
Yes.
It is very difficult here in online. you come to India, this one is that anchor point.
Anchor point, yes.
Okay. What the amount? So we have to start from this arrow.
This arrow.
This one.
Okay.
We have to first model. We have to model the pipe from starting. We have to model the pipe.
Then
After completing all piping,
Okay.
we have to come for the equipment.
Okay. Then equipment, how you will start from the
Yeah, I'll tell. First we will complete the piping modeling. After that we will come to the equipment. Okay, first we have to give the entire piping. You have to model the entire piping. After that you have to give the support as per the feasibility or the given in the isometric. No, availability of steel. Based on the availability of steel, you have to give the support. After that you have to come for the equipment. Okay. This is the procedure we have to follow, and so node numbers you can give anything. I mean 10, 20, 30 like that, like 10 series or 10, 30, 50 like 20 series or 5 series. Better you go for 20 series. 10 also, 10 standard one. If you want to insert anything, no, then the 20 series will be more comfortable for you. Yeah. Okay, and equipment always start from the higher node. I mean about 10,000 like that. Piping and all. If your system is very big means then finally we have to decide. If the system is very big means we can start 10 series also or 5 series.
Okay.
Because up to 32,000 nodes only we will be able to enter. Okay, so we will start this one. Okay, first you have to create a unit file. Initial thing, no, that you have to create one unit file. That is the first procedure. You know that?
Yeah,
Tools make. Yeah, tools. Make unit files.
Unit file. Yes.
In that, create a new unit file. New unit files.
Okay, existing.
In that, you just note it down. mm.file, and after that you have to enter which unit file you want to make. I mean, any name you can give.
Okay. Okay. We will generally use MM or based on the requirement?
No, based on the project requirements. If it is in feet and inches, then you have to go for that English unit.
English, yes.
Okay. So now, but we have to check the line list whether what are the units they used for this one. Line list I don't have. Okay, from the isometric we can get the details. Here also I am not here also not given anything.
They are showing in MM only.
only. This is a line list. Okay. This is, from the line list, you can take this one. You have to note it down. What are the units they are using? You see, temperature in degree centigrade and pressure is in kg per centimeter square. And what is the density? Density they have not provided. Okay, for steam, no, steam density will be less only.
Yes.
The density will kg per meter cube will consider. Okay, all are mm only, so we'll consider those kg per centimeter square. Okay, so we can give your name. What is the
kg per centimeter cube?
No, that is for density.
Okay.
Yeah, sure. Okay, I will give your name. Okay, just after giving the name, you have to give weave or edit file.
Correct.
Okay.
Yes. Here you should select.
And this you have to select. Pressure they are given in kPa. You see,
Yes.
that will change it to Newton per centimeter square. Elastic motors and all, you will just leave it. And pipe density kg per meter cube we can change. Insulation density kg per meter cube we can change. Density and all. Fluid density you can change to kg per meter cube. And other things remain same, so no issue. And uniform load. Uniform load we can, okay, that is not required. I'll make it as Newton per mm. And temperature it's okay. Force in Newton. Stress will change it to Newton per square mm. Newton per mm square will change. And other things okay. So now we have created one unit file. You have to give okay, save. Okay. So it will be available here. You see, the path is like this only. Wherever you save, no.
Caesar training.
Initially, yeah, Caesar training. In that location, it will be available.
Yes.
Caesar training. Not data. Here you see.
Yes.
Shivkant.fil is there, no?
Okay.
So you have to use that file.
Yes, for all the.
Oh yeah, you can copy and paste in some other folder also. And do that one. And copy this one. Copy. And we'll create one new folder. Sure. Okay. Then we have to, or we can copy that already created file. No, that also we can use. Here C2 is there, no .c2. You can copy that file also.
Yes.
We'll keep it here. We'll paste it here. You can use that file also. Sure can't. In that lines is there, no?
Yes.
Already created file. Just open that file and input. Here is this is the input. 1, 2, 3. Third one is there, no? That is input. Properties for materials change in the database. I think previously they used 5.0.
Yes, correct.
Because then only it will ask from lower version to higher version. No, maybe they upgraded something as per 13.3. So okay, yes you give. Yes or no, keep the original material properties. Okay, so it will be like this. Oh, what is this?
What was that pink one?
No, that's what I'm asking. That is nozzle, I think WRC 297 they qualified, I think. Yeah, you see. Here you see WRC. No, yesterday I told, no, this is Welding Research Council. If they are not able to qualify the nozzle loads within the allowable, then they will go for this one. They will qualify based on WRC 297. They will send this report to the vendor.
Okay.
So based on this report, they will say okay for this. No, that is not support.
Oh, yeah, for that pipe there is
Oh, this for that header. Yes, maybe it's not required.
Yes.
Oh, yesterday you sent on Snap. That is this.
This one only.
Oh, okay. But what is the line size? 20-inch line, huh?
Yeah.
Okay. But they have not provided the support. They qualified. This one.
That is the result.
Oh, yeah, that is okay. But they given only rest, all are rest supports. but something is there. Because all are support, but as per practically it will be U-bolt you are telling, no?
Correct.
Then this will be wrong.
Then there will be a problem.
Definitely, if they provide U-bolt here, no?
Okay, yes.
This line, I'll tell you this yellow highlighted, no?
Okay.
Your anchor is this point,
Yes,
okay?
correct.
This green color, no?
Yeah.
Green color square box,
Yeah,
sir,
yeah.
no? That is anchor.
Okay.
So this pipe will move in this direction,
Correct.
downwards only.
Correct.
Okay. If you are providing any U-bolt here,
Yeah.
that okay. U-bolt means it will arrest this movement, vertical movement.
Okay.
So what will happen? Some reaction force will be here, will be acting, and this nozzle will fail.
Okay. Then what you should do on the
No, they have to check. We have to check this one. I'll check now. 660 is there now. Okay, I'll check that. 660. Guide is set. I think temperature is less. 120 is there now. Okay, I'll check this. I'll run this one. See. What is the node number? 75. Check. Because we don't have allowable loads now, so we could not check that one. Maybe I'll check this one. 75. At 20 there is no 75. If you see, it's in feet and inches. You see the moments are like anything. I don't know how they have qualified.
Then how the
Line is passed means stress will be passed. You see, stresses are okay. Stresses also we have to check.
not okay?
Displacement, everything will be okay. You see, stresses are very less.
Yeah.
All are passed only.
Okay.
You check the code compliance. It will show pass only. But this nozzle allowable loads, no. If the code compliance evaluation cost, maximum stress is 35.2% only. Okay, so that is not a problem, but the only thing they have to, this nozzle, no, they should qualify. I don't know how they have done. This is the third party, yeah, this one?
Third party, yes.
Then be third party.
Yes.
Oh, you are offloading this job to them.
Yes.
Oh, regularly you are offloading, yeah? This job? Oh, okay. Okay, we'll start from first node. We'll delete all the thing, all this. I'm going to delete all the things. Yeah. Okay. File, new. Okay, we'll give one name. Siva Mona. Okay. You give okay. No, okay. You give
Similar folder.
Oh, but same folder I is created because it's index. Wait, we'll check. We'll check. Yeah, same file only, but it is created. Okay, we'll check this one.
Configurations.
Configuration setup. In that database definitions will be there.
Yeah, that units.
In that
Yes.
Shivakant, no, I have to do that one. Okay. Or you can same thing. Shivakant only.
And what other configurations you do?
Oh, you see now the unit has been changed.
Okay.
Yeah. What is
Okay.
other configuration?
Any other configuration?
No, yesterday I shown that as per that only
As per
the stress design basis they used to give. As per that you have to
If not,
start. If not given means okay, default values we have to take. Okay, just a minute. I have on design basis. I collected on this on Network Solutions. This is a piping stress design basis. Same thing.
hello? Hello? Hello?
Like hello.
Yeah.
Oh yes.
Now,
Yuval.
now it's okay.
Can you able to see my
I can
Screen.
see detailed review.
yes, yes, yes. I can forward this one. You just go through this. Okay.
Okay.
If you have any doubt, you just we will discuss tomorrow or day after tomorrow.
Sure,
Okay.
sure, sure.
We'll start that model.
Okay.
After that. Okay. Apart from this one, this node number is there, no? Just a minute. The FRP, no need to touch this one. If you are doing any FRP lines, no, then only you have to use this one. This one. Then database definition, only this unit file name we used to change.
Okay.
Other things remain same. Okay. And miscellaneous. If you want to increase your memory, maximum memory, you can use 512 only.
For what?
No, if
RAM?
not RAM, this is memory allocated for this Caesar.
Okay.
If your this one, I mean, if your system contains more node numbers, no, then it will hang. Okay, for that purpose, you have to increase this one. And then nothing other than that.
And node 10?
Where
That,
it is?
somewhere.
No, wait, I'm telling you, it is there, it is there only. Computational control. In that computational control, no need to change anything. Frictional stiffness, everything. Only if you want to give friction, coefficient of friction 0.3, no?
Okay.
You can here you can mention here itself. If you give automatically, it will show the point. It will show 0.3 there. If you are entering any support plus y like that, no, it will automatically show the friction point as 0.3. No need to mention 0.3.
Okay.
Okay. And then shifts and stresses. Here also no need to change. Whatever is that default value you have to use. And geometric. In this geometric directives only,
Node number.
this node number automatic increment is there. No, you can fix it to 20. Okay. And 3D we were setting this colors. You can change if you want to change anything. Okay. So I exit. It's save. Now this is a first node number. Okay. First, first we have to enter the diameter, schedule, corrosion, installation thickness, temperature, pressure, material, everything. After that, you have to give the dx, d by d.
Correct.
You know that this one, this axis, you know,
I know this. I know.
x, y, z. Okay. And it's fine. We'll go for that one. We'll start the pricing. This is a come to India, no? You place the thing.
Actually, I have tried. I came to India, but no right. We having 15 days. If I came to Bangalore, in 5 days should go.
No. If you inform me earlier, no, then I will come to Hyderabad also.
I will ask him.
Okay, no problem. Because I used to go to Coimbatore within Tamil Nadu. Within Tamil Nadu, anywhere I'm going, Madurai, Coimbatore, Trichy, those places I used to go.
Okay, if you can go to Hyderabad, I will.
Definitely I'll go.
Okay.
Some 2-3 days if I spend, no, then I will complete this one easily. Because through online it is very difficult, but directly means you can ask more questions and it will be a very much interactive session.
Yes. What to do?
Yeah, we can. Because already I took these classes for Canada. 2 persons I took. It lasted for around 15 days. Very, very boring.
I think they are not.
No, 20 years experience one person and they are into piping. So they want to learn Caesar and they are doing some project. Based on project requirement, they ask some questions. And they started, they've done one system also in the practice session.
Oh. Canada people are Indians or other people?
No, Indians only, Indians.
Okay.
From North India. Oh, yes. Okay. Okay, first we'll start this node number. You know how to mark the node numbers and all? Yeah, if any flange is there, from starting point it will be 10. No, this is 10 and this one is 20.
Yes, correct.
Like that, and this one is 30.
Yes,
And
next weld will be the.
Not next weld. Okay, this is a small bore. No need to model. If any big bore line or any T is there, then we can model. Or we can directly go to this end of this elbow.
Okay.
540 is there. No,
So,
there.
if there is a connection,
Fixed connection. This is a small bore line, no?
okay.
You see, this is think of 14. This is 14-inch line, main line, and this branch is 3/4 inch. So that is very, very small. So no need to go. If it is a 2-inch line means okay, we can consider. Yeah, about 2-inch means we can consider.
Then we should give
SIP. Yeah, we have to give the T.
Okay.
SIPs and T's are there, no? We are doing that. Okay, first we'll start this one. 14-inch. This is a 14-inch line. And material is 106 grade B and schedule is 9.53 thickness. Okay, first we will give the 14. You know, this 14, if you give 14 it will automatically take down. 14 and standard thickness I think so, 9.53 thickness, no, that is standard thickness. And corrosion is 3 mm. Insulation thickness, just a minute, please hold on, just a minute. Hello?
Yeah.
Yeah. And then the insulation thickness, I have to check this line. This is 141101. This one we'll check in the line list is there, no? The line list 1411. Which one is line number? This is isometric number. 14101. Okay, I will take this one. This is the line number, I think so. Is it 14-inch SL 63141?
Yes,
That 1411 is the line number. Here 141 is not available.
1411 is there, no? A.
Is there?
PS.
Where?
No, PS.
Oh, this is line number. Okay, we will.
Yeah, we'll take some.
No, it will be insulated. No, it will be insulated only. No?
Hard insulation.
This is, yeah, we'll take, this is steam line, LP steam line. So it will have some 25 mm insulation. We'll take that one. So 25 mm insulation we can give. And temperature.
First one will be, T1 will be?
No, that depends on your project. I mean, in the design basis itself, they used to mention T1 is design temperature, T2 is operating temperature, and T3 is minimum design metal temperature.
T3 is what?
Like that they will mention. MTMT, minimum design metal temperature. But temperature it will be in the negative, it will be very low. This negative temperature will be there.
Okay, we should give all the three.
Yeah, it's required. Definitely, we have to give all the three.
Generally, we'll give a design and operating.
Ah, yes, yes. If you want to know what is the, I mean, reality, what will be really acting on the expansion you want to know, means then we can give the minimum design metal temperature.
Where will
Because
that's standard one, right?
no, not standard one. It will be given into a line list itself. If they have not provided, means no need to give that one.
Okay.
Because in our projects and all, they have provided that minimum design metal temperature. That will be in the negative. So in the negative means it will contract.
Yeah.
Okay. We have to check the contraction and also expansion.
Correct.
So simultaneously it will act. So we have to check the
Minimum metal temperature.
minimum design metal temperature. MDMT. They used to tell. Minimum design metal temperature. MT. Okay. And temperature we have to enter. We'll take temperature as this is maximum is 200 degrees centigrade.
Correct.
So we'll take that one.
Yes.
Okay.
200.
200. And operating temperature will consider as 150,
Okay.
for example. And the pressure how much they go? This one, no?
Pressure 4.
Operating is 160 they have given. We'll take it as 160. Pressure is that is design pressure is 7.5. It's 7.5.
Operating is 4.
Oh, yes. Already we have defined that unit, no?
Yes.
So we can directly give Newton per centimeter square. And operating temperature, no need to give that one.
Okay.
And this one is hydro is
1.5 times.
1.5 times.
Correct.
Okay.
So you can directly
And,
multiply over
material-
there.
Ah, yes, yes. You can add, subtract, multiply, anything you can do. Division, everything you can do. And your material is 106, no?
Yes.
Just 106 only. 106. You see 106 date. If you enter 106, it will automatically take, you know that.
Yes, yes.
This is a number. Left side is there, no? That is a number. Okay, then fluid density is 1000. I'm taking maximum. I'm taking the water density. It is steam only. Anyway, I'm taking the maximum.
Because there will be
Maybe, yeah. Two-phase flow maybe.
two-phase flow.
Yeah, insulation density we have to give. It is mineral wool. It will be mineral wool only. Okay, you can take 140. 140.
Okay.
Okay. So now we have modeled this. First we have to model the flange. First flange. You see, this is the equipment. Mating flange is there. No, this one you have to model. Total is 660. You see, this vertical length is total length is 660.
Correct.
Okay, so
That is up to.
first,
Then we should minus the.
yes, yes, yeah. You see, I'll take this flange, from database itself. Okay, we'll check what is the rating of the flange. F3.
So we can take flange also.
Yes. You see, 14 inch and this rating is 150 rating only. This flange rating. Okay, so we'll consider that one. You see here, left side is there. No, valve flange database is there. You see, left.
Yes.
You have to click that one. Okay, yeah, it will show this like rigid weights, no? This gate valve, flow ball, check valve, control ball, everything will be there. For flanges, you have to click flange, here FLG, flange, and 150 rating. If you click OK, it will directly show that. But the direction is different. You have to cut and paste.
Correct.
You have to cut and paste, yes.
Correct.
Okay, so it will be in the upward direction only. And for the first node, you have to give anchor, node number 10. The restraint, you have to double click the restraint. Okay, node number 10.
Node number 10. Yes.
N, and you have to give anchor. A means anchor.
Anchor, there will be no gap, right?
Yeah, anchor means that will be 0. That is welded, no? Okay, this is node number. This is node number 10, and we have to go for the next node number. Okay, for next node number, Alt C. Alt C. Alt C.
Next node.
Oh yeah, if you want to go to the next node, Alt C.
Alt C.
Oh yes.
Okay.
You can check tomorrow in your office.
Yeah, I will try. I will definitely.
These comments, yeah.
I will
if
go
you,
online tomorrow.
Yeah, because if you practice no, then you will get more doubts.
Yes. At least in 1 hour.
Otherwise,
beginning I can.
Definitely, very easy.
I will do it.
Yeah. Okay. Then next, this flange is 130 mm, and our total length is 660.
Okay.
You see, minus 130 plus 660. Yes. But you have to be correct. The sign, no, that symbol should be correct. Okay, here you have to click the bend. There one bend is there, no?
Then
okay.
You can take short radius.
No, short radius it's not required. No, it is long radius. No, it is long radius only. 533. 533. We can make it as 533. And then only it will form. Then next is.
What's come before?
Huh?
Okay. Now you have given. Okay.
First node is this one.
Okay.
This anchor point. Flange.
Bend you have given.
Yeah, you see, bend only I given.
Okay. Second node.
Yeah, next. We have to go for next.
Next node, and we should do the coordinate.
No, not. Yeah, this length. This horizontal portion is there.
Yes,
1013, 1013, 1013.
Yes, 1013.
Yes, you can add here itself. Which direction? Minus x.
Minus x.
It's going in minus x. So 1013 plus. Sorry. 1013 into 2026. That will be minus here. No, minus we have to enter.
So then
here also.
You told first we should do the coordinates.
Yeah, we can give coordinates. Just a minute. And we can give it anytime.
Anytime, okay.
At the end also you can give. After completing the modeling also you can give. Yeah, left side you see this global coordinates is there, no? Yeah, the global coordinates.
Okay.
Left side.
First point we should do that, right?
Yes. No, if you enter it will directly go to the first point only. if you click this global coordinate, no, the global coordinate is there. If you click that one, it will show the first node number only, node 10.
Correct.
Okay. So node 10 you have to enter the values x, y and z as per the isometric.
Yes.
You see here, the isometric they given these three values, no?
Elevation.
This one easting, northing and elevation. Okay, you have to enter all the values or okay. What is that? Just a minute, not this one. 16. No. East you just note it down. 1822
No.
638.
That is 1. Yes, 638. North is 1656 250.
250.
Elevation.
Okay. And what is x means that is northing only. You see?
Yes.
Always
1656 250.
Minus you have to enter. Okay, that is in north means minus x only, no?
Correct.
Minus 1656. Okay.
250.
250.
Okay. Can you tell me coordinates once again?
No, yes. North is minus
Y
x.
is up.
Y is vertical. Yeah.
Up, right?
Yeah.
And east
Y.
is
East is minus z.
minus.
Minus z. Yeah, y. You tell the elevation value.
1059.
105910. Okay, what is the east? 1822
638.
68638. Okay, so we have to click OK. Okay, we are given that code. So we will check once again, not once again, after modeling everything. Okay.
Then we can next one.
Yeah, up to here we have modeled. This one up to 540 here, no? Then again we have to come down. Okay.
That is also small board.
Yeah, that is also small bore, so we neglect that one.
Okay, that is
Then 4874 plus 1022.
4874.
4874.
Okay.
Okay, go to next node. Minus 4874
minus 1
minus 102. Okay.
Correct.
Here also one elbow. Here also one elbow, and after that it is going towards minus z direction.
Z. Z?
Here is it. Z.
Yes, sir.
Yeah, this is x, y, z. No, so it is going towards x, z direction. The length is 962, including this flange. Okay.
Then, okay.
Yeah, we will subtract that one. Minus 962. Minus 962. We know our this one flange thickness 130 mm something. This will be this direction. Okay. So our flange is 130 mm. So next we have to model the flange.
You can directly take from
No, this is the database. Flange 150. Okay. No, how it will be happen? This is not connected to equipment. You see, this is going to some other
pipe.
next sheet.
Okay.
Yeah, it is going to the sheet 3. Sheet 3.
Okay.
So it is connected here.
Yes.
Okay, here only. And in between one the spectacle blind is there.
That one
Sorry,
also
here.
is model?
Yeah, you can model. If you have pipe data pro, you can tell the weight.
Okay.
You see here, this is
That is also
that is 23 mm.
rigid.
Yeah, rigid we have to model. 23 mm we can model. 23 mm. You have to give 23 mm.
Pipe that up.
And give some weight. I don't have pipe it up.
Which version you are using? Pipe that up.
No, I don't have now. In office 8.0 something.
Oh. See if you
okay. Thank you. Okay. Thank you. So we have modeled this spectacle blind. Then one valve is there. See, next sheet. Oh, no valve. Again flange only. No valve, no? Only flange. Yes, flange. Not reducer, that is flange only. After that only reducer is. We are at this flange. Where 160? No. We'll go as per this original dimension. Okay. After that, we'll check. Okay. Why they are going like that, we'll check. Okay. 830. 830 is there. We have to subtract this flange thickness also. I think so. 130 plus 830, no?
Yes.
So it will be 700 here. After that, on reducer, that I don't. Approximately, we have to take. We'll first we'll consider some length. We'll consider some 150. After getting this flange, reducer, you have to click the reducer. And what is the size? 12 inch line.
12 inch.
Yeah.
I think flat wise down. The reducer is flat wise down. How we will?
Yes. 16 mm offset is there, no? Yes. So your reducer is there. You have to enter the next diameter, 12 inch, and standard thickness, and it is flat side down, no?
What is alpha?
Alpha will not required. That is the angle.
Okay. That is not required.
That is not required. Okay. Automatically it will take.
Okay.
And for the offset, you have to give minus 16 mm in the y direction. You can see now it will show flat.
If you will not give offset, it will take 0.
Yeah, direct. That will be like concentration. Okay. But exactly this dimension we don't know. After getting this one flange thickness, we will add that one. Okay, flange 12 inch. So this is 12 inch line. No? Reducer we have added. That is 12 inch. Okay, go to next node. This flange 150 rating. This flange is 117 mm.
117.
Okay.
Then we should reduce 117 from 4.
How much that one? This is 461. Okay.
461
minus 117.
Yes.
Minus 117
plus 461.
461, no?
61, yes.
Okay.
Yes.
This is. Let's check this one. Whether it is flat side down. Yes.
Yes, flat side. That one also, that offset we should check in.
Oh yes, everything will be available. If you click eccentric reducer, it will show the offset. Okay, then one control valve is there, that is 780 mm diameter. Next is control valve 780 mm.
Control valve is ball valve, right?
No, here control valve also it's available. You see, control is there, no gate, globe check, control. You can take control valve, but no database values. I think it's not there. We'll take global weight. The global weight will be more. Dimension only will take it from the isometric. Weight will maintain the same. This dimension I updated, you see, 780 mm as per the isometric.
For I think most case,
No. Always we used to give manually only.
for all valves.
Yeah, for all valves. Definitely we will have adapters, otherwise we will follow pipe adapter. If client specifies that you have to use a Caesar database, then we have to use Caesar database. Because for flanges and all, in Caesar database they have not included the stud bolts bit. Okay.
Correct.
So we have to use the pipe adapter only. Okay. So next mode we are going. Next is flange again. Flange integrating. After that again reducer. You know the reducer length now. 344. 344. And your offset is 16 mm. Now we have to give positive value. Understood? No, previously, if it is flat side down means here it is minus 16. Okay. So this elevation you have to maintain. No? So now reducer and you have to give 14 inch and standard thickness. You have to go for the next node. And next node is 1992 is there, you see.
Yes.
One T is there, 2 inch T, 14 by 2. That one also that is maybe, yeah, I think so. 3, what is 3? Reinforcement pad, yeah, reinforcing pad.
Yes. Stop.
Yes.
1992.
1992. Okay. 1992. Okay. So here T is there. If you want to mention T, you can mention. Otherwise, mention. But we are not going to model that one.
Okay.
If you want to give reinforced T means you can give reinforced T like this also. Reinforced, and we have to give the pad thickness. Sometimes, what the vendor, client, no, sometimes they ask you to enter this SIF I and SIF O is there, no?
What is that?
That is stress intensification factor. I mean,
From where you get that?
what is? No, every T, it is automatically defined in the CSET database as per 31.3. Okay, if you want to review any T, no? Just a minute, I will show that one. It's a T review. No, that is shortly. No, not that one. One review will be there. In that, if you enter that value, if you enter that node number, it will automatically show what is the stress intensification factor values.
What is ISO?
That is a in-plane stress intensification factor and out-plane stress intensification factor. You just refer 31.3. It will be given clearly. Here you see. Not in stress topic will be there, and that it will be covered. I will tell you the page number tomorrow.
Okay. When you sleep every night?
10:30, 11, mostly 10 to 10:30.
So you will cook every day, or you are?
No, outside hotel.
So you order today?
No, already. No. I'll go there and. No, bike.
Like you have.
That since yeah, SIF scratch pad is there. No, here you see this one. If you enter that one, it will ask the note number. You give 300. This 300 only we have entered the T, no? Found one pipe intersecting into the node 300 continue. Yes, to give this, it will show here right side you see SIFI 4.915 6.22.
That one we should enter there.
It
or
auto-
it automatically?
No need to enter that one. It is default values. Okay, no need to enter. If a client asks you to calculate the SIF, then only you have to calculate that one. That calculation is there as per 31.3. Okay, that mostly they will not use to. They will not ask you to do this one. For flare lines, no. Sometimes for flare lines they ask us to do this calculation. Because flare lines only we use the lateral edge and all, no?
Yes, correct.
Maybe some expansion or occasional cases it will fail. So in those cases we used to give this reinforcement pad and all. For those cases they used to calculate. Otherwise you will leave it. You have to give this pad thickness only. What is the parent pipe thickness that we can give? Okay. Just for your understanding only I am giving. No need to give this one also. It will not take any problem. Sometimes it will be not all the cases. Okay, up to T we have model. Then yeah.
Oh, hello?
Hello.
Yeah, I'm getting.
Next is 721.
721. Yes.
Hello?
Yes, correct. I'm getting.
Hello.
Yes.
Yeah. Can you hear me?
Yes.
Yeah. Next is
721.
721.
And then is
1850. That is not my rate.
okay. 1050. I think.
Oh yeah. Just no. No, 1850. That is 1850, not 1050. 1850. You are staying with your friends or with whom?
I'm staying
Or
in
alone?
accommodation. Yes. We shared accommodation.
Oh, okay.
What about rents?
How many
Bangalore?
persons?
With 3 members.
Oh, 3 members. Oh, okay. Rent? No, this is one simple home. 5,500. There it is okay, man. But you are getting more, no?
No.
You are getting more salaries.
Yes,
India is always better only. If you want to earn money, means you have to go outside. Then only you will get. Otherwise, here we can't save. Next is 2874. You see, in the Z direction. 2874. not Y.
Oh, not right.
X 3090. Okay, after. Here I forgot to give. Yes. Next page it is going. The reducer is here.
Yes.
Reducer is 356 mm. The line size is 16 inch. It's increasing. Okay. How much? That one? 356. No? Yes. The reducer and the line size is 16 inch diameter and standard thickness. Okay. And any offset they given? Yeah. How much? 25 mm offset is there. This is 16 by 14, 25 mm offset. So we have to give the 25 mm offset here. 25 mm. Okay. After that, T is there.
Minus you should give.
25 plus. Minus no. Plus only. No?
Flat side down, no?
I given minus I think. Plus only, no?
Yes.
You see. You see like this only. If you are going down, no, then only you have to give minus. But there we have we started from here.
Yes.
That will be minus.
Yes.
Okay.
Correct. I got it.
And after that one T is there. That is 305 mm. 305 mm. Okay. This is T. So 420.
Okay.
What is the time now there?
It's 7:50.
Oh. Okay.
For you,
So daily what to 920? Yeah.
9:20. Yes. Daily.
Oh, okay. So next, next we have to check. This is whether it is, symmetrical or not. You see, it is going to this next page, no?
Yes.
Next page, yes, sir. You see, this is like symmetrical only. Understood? This is first. This is our first node, and we started like this, and it is coming. It is connected to this reducer. Okay, this reducer. After that T. So after this, that is copy and paste, like a mirror only.
So you can do that, right? You can copy that.
Yes.
Yeah, that one.
That's what it is.
I should.
Yeah. This is T is there. No, so you can copy the entire thing. No, from 10 to here only. Only thing, okay, we'll check that one. We have to copy like this. Left side you see list input is there. That elements. You select all the up to 420. Right click it. Right click block operation and duplicate. We just wrote, write it down, otherwise we will forget this. Okay, this is this one. We want a mirror. In which direction that you have to select. This we have to copy from X, Y, Z. Y and Z, I think so. I'll check.
Y and
Let's see. Duplicate. Mirror Y, Z. We'll check whether that is correct or not. Y, Z. No, not Y, Z. We'll check. And this node increment, we have to give different node number for this set.
Different
Okay,
node
here.
number? Not
No, different node numbers means if you are not giving any increment, it will take the same values, 10, 20, like that only.
Okay, then how we should give from here?
So,
420?
yeah, you can add 1000. You can add 1000. 1000 means it will start from 1010, 1020, 1040, like that.
Why we should not give 440?
No, for easy this one. For easy node numbering, if you remember, you can remember this one. 440 means again it will get confused.
Yes, correct.
If you are giving 1000, no, at the end final node number it will be 1420. Okay, so in the 1420 final node number should be connected to this T.
Yes.
Okay, that should not be 1420, it should be 420 only.
Okay.
Then only it will get connect, otherwise it won't connect. Okay, I'll show that one. You see whether we are given. Because you see last node number you have to select 420. Connect like this only, but hello.
Okay.
5 minutes.
Yeah,
Hello?
continue.
No, I'm hearing some of the sounds.
Yeah, yes.
Okay. Oh, okay. No issue. Here you see, we have to check. Now it is almost completed.
Correct.
No, this one we have to check whether this.
Oh, they are connected to two vessels?
Yeah, two vessels. Here you see, this one we have to check whether this is correct or not. This side, not that side, this side.
So we should...
You see, this is connected in this direction, I mean opposite direction. Okay, it is connected to X direction, you see.
correct.
From X to minus X. So you have to change that one.
From the bend you should change.
That is very simple only. Just you have to change this direction only. Minus, if you are put minus, no, then it will be over. Okay, this is it. I think one more ISO is there. Check this one. You see, first we have started and we have completed up to this. Here also we have completed. And here also we have completed. And next is this reducer. You see, after the reducer, one tapping is there. That is going. That is going to some other point. I mean, this is end of scope. I mean, tying point. You can call it as tying point. Okay, we will model up to the tying point.
Tying point, how
No, by anchor only, not anchor. Rest. Hold on, guide, stop. Three-way stop. Yeah.
battery limit is stopped by?
Hold on plus guide plus stop. Now we will model this one. We have to model this line.
Okay.
Understood?
Yes.
Okay, this is going in which direction? This is going in Z direction. Okay. Could you please hold on?
Yeah, sure.
I will come just a minute. Hello.
Yeah.
Yes, sorry.
Okay.
Also, we have to start from this
Yes, that's T. Correct. That's T point is
420. Okay.
you should copy that.
No, 420 will we'll go to the last node, control end.
Yes.
Okay.
Then
Then we'll start that one. 422 last node what they went to 1400 is there. We'll start from 2000 also.
Okay.
2010.
Okay. So we can give any node number.
Any node numbers, no issue. But it should correct. It should be correct. It should not be repeated.
Yes.
Okay. If you give this like this, no, then you can easily identify these lines. If you have different line numbers for these two lines, no, then you can easily identify this. Okay. This one is 914. This direction, Z direction, 914. Bend is there. You see, this is 914. And after that, 900 is there. That no need to model that one. After that, 3950 on support they are given. Okay, 3950 plus 900 you have to model. 50. Where? Where it is given? No. 5170 it is from this Veldolite 2 there.
Okay, support.
In between one support is there.
But okay, support you will support.
Yeah, we can split or we can give. We can finally also we can give. We can split that one. Okay, 5170 plus 900 is there, no? Minus 5170 minus 900. 6070 on elbow. After that, it is rising 3300. It's rising 3300. 3300 on elbow. After that, 2312. It's in horizontal direction, minus x direction. 2312. Minus 2312. Next is 6121. This direction is 612. Z direction. 6121. Okay, that is the. I think that is the battery limit. I think so. Okay, next it. Oh yeah. You see, this is their scope, and they modeled up to here. You see, this is semi-anchor they given. No.
Yes.
After that semi-anchor we have to model. Okay, here only they have given the battery limit. This arrow is there, no, and the battery limit. But we have to model up to the semi-anchor. Their semi-anchor. Okay, for that purpose we have to give 3400, 4000. So like that we have to model.
Okay.
We'll model 3400. After that 4000.
Yes.
1, 2, 4000 for that. What is the node number as well? 2090. 2090. Next also So this is the final one. Now we have to check whether we have modeled correct or not. Now we will check the coordinates. So it's okay. We'll check. We'll check at this point or we'll check at the end point. This equip. This one here you can check. Okay, 1 8. 1 8 3 8. Okay, we'll check that one. Here. Here in this Alt D, you have to give Alt D. That is for distance. Yeah, distance. Alt D. Okay. If you want to measure some distance, means you can give the two node numbers. It will show the distance.
Okay. Alt D.
If Alt D. No, that's what I'm telling them. If you want to measure two nodes, means you can measure. If you want to check the coordinates, means just Alt D and enter. Don't need to do anything. Just enter. So it will show the coordinates at node number 1020. Correct? This one? What is 1822638. So whatever we have modeled is correct. We have to check other dimensions. I mean, x direction and y direction. X direction is 1648750. 1648750. 1648748. Okay, 2 mm.
Okay.
2 mm, no problem. Okay. Up to 50 mm or 23 mm they can allow in this modernization. And elevation is 106047. Elevation is somewhat mismatched. You see, elevation is 105910. How it does? 105910. No? What is there? Here 106040. 5910 minus 1060. Oh, 130 good. No? You have to check. You have to check this height whether it is correct. 5896. We didn't check the dimension. No, you are 5896. Here 4874 plus 1022. How much? 4874? 1022. 1022. How much? 48741022. Correct only. 5896. Then we'll check this dimensions. 1850. Only y distance is the problem. No? So here also 1850. Correct only. Look any moves that. Here you see this is in the upward direction. Here it is going towards from x to minus x only it's going. So that will be correct only. No? First to correct only. Correct only. Yes, this is maximum.
See the global coordinates, maybe you have got wrong.
105910. Correct. Elevation is 105910.
No, you just copied, no, then why you say wrong?
Wait. 10. Yeah, it is 105910 only. This is 660.
Just copy.
Oh yeah. 102528. Or this is maybe slope line, no? Here the elevation is 102528. We'll check the elevation at this point. 10. Oh, correct only 102528. 27.
Correct.
Okay, it is 1 mm only.
Straight view exactly.
Right. 106040. Your error is mismatch. Oh, okay. Because
That is wrong.
you see, no, everything is correct. Here, no. Here, if you measure this one,
Okay.
it will show the coordinates for 1020. Here, 1020 is, you see, it is in the vertical one, 130 mm minus. You have to subtract that one.
Correct.
Understood? No, this one.
Yes, I got it.
It is showing the coordinates, at 1020. Ours is 1010. We have to calculate. So I think that is correct only. Then it is fine. So this modeling is over. Then we have to give the supports now.
Equipment.
No, we'll give the support. Finally, we'll go for the equipment. Yeah, we can model the equipment also. After that, we'll give the support. Okay. Equipment, whether we'll see today or.
Tomorrow.
Okay, we'll see.
See, that's your wish.
No, tomorrow what? No, tomorrow I will not be available because I told Thursday I will be going for an interview.
Oh, yes, okay.
Girls speak. I told you. So 9th is the interview.
Oh,
So I will be back on Friday only.
On Friday.
Okay, tomorrow Thursday for you. Thursday is all day. Huh?
Thursday is not, Friday is holiday.
Only Friday. Saturday?
No.
No, only Friday holiday. No. I thought 2 days.
All the maximum all the companies
Few companies I think 2 days holiday. Very few companies. Okay, no problem. Friday I will come. I will try to come early.
Okay, sure.
Friday I will take permission.
Friday.
Oh, you won't leave? Okay. You can take rest. We'll see on Saturday somewhat early.
Okay.
Okay. Because tomorrow and day after tomorrow it's not yet. Okay.
No problem.
Friday night it is okay, no? For you?
Friday night.
Huh?
Okay. Friday night. Or else,
Same time you can.
okay. No problem. Or else you can start Saturday.
Okay. Okay, now we can start this equipment modeling.
I will practice. No problem.
Yeah. Yeah, I'll start this equipment modeling now. Okay, just we'll take the equipment. Same thing only. Just you see. That's what I'll tell this. So this is from here only we have started with C, no? This. So now we are going to model this equipment. Okay. No, that is after this equipment. from the starting of the equipment. Now we have to go for whatever details given in the equipment sheet. Everything we have to follow that only. So first node is 10 node number we have entered. No, we have to enter C node for that. C node means connecting node. If you give anchor, if you want to continue further, means then you have to use C node. After from that C node only it should continue. If you are giving 11 means then you have to continue with 11 only. No, C node is 11. We'll go to the lowest node, control end. Okay. We'll go to the next node, 11. 11 we have to start. 11 and equipment will start from 10,000 node. 0, 1, 0, 10,000, 10. Like that. Okay. So we have to start from here. You see.
Actually,
Now we are going to model.
In one system, it should be finished, right? System.
Yeah, no problem. You see, now we are going to model this equipment like this. But which direction I don't know. Maybe this direction.
That direction.
Yeah, east west I think so. But this direction will be a problem. So we are going to model this one. You see that C, nozzle C, no? What is the projection we have to check? C, steam inlet and nozzle projection they have not given here. C, 14 inch, 150 rating and wall thickness is 19.05. That we have to follow. Okay. And here anything they given? See, here you see they are given this one 1425 from the center line of equipment.
Yes.
Okay.
From the center we should give or?
Yeah, from the center only. Wait,
We should minus the.
I'll tell you. Yeah, I'll tell you. First we have to model the flange. This mating flange in the downward direction. Okay. Okay, now flange came. Okay. Next we have to model that pipe portion. Approximately now we'll take 150 for example. Or we'll take just a minute, we'll calculate that one also. 1425 is the nozzle projection. So what is the OD? No, what is the OD? This one we have to check. OD is 2438. Okay. What is the 2438 divided by 2? 2438 divided by 2. 1219 minus 1435, no? 1425, sorry, 1425. 206. So the projection is 206 mm. Yeah, 206 mm. Out of 206, flange is 130 mm. Okay, remaining portion is the pipe. Okay, minus 206 plus 130. This is pipe. Okay. Again, you have to give anchor at this point. 10030. Here only we'll check the nozzle allowance. And you see, I have given anchor and also C node.
Okay.
Because we are going to continue. We are going to continue from here.
What is the one more anchor? Reinforcement pad?
No, not reinforcement. Yeah. That is not reinforcement
That
pad.
means,
Normally it will not be reinforcement.
Yes.
If requirement, they will provide the reinforcement pad. Otherwise, there won't be.
That is there. But that might be the point where it is getting the.
Yes. I think here they are given. RF pad, yeah. Okay. And you see The starting 10,000 node number is in, you see the line size, it is 16 inch, but our nozzle is 14 inch. We have to enter. Because previously last node number it is 16 inch. You see this is 16 inch, no? So that it will automatically take the last node number only. Okay, you have to change that one. You have to be careful. Okay, now I will change this one, 14 inch. Yeah. After that, you have to continue this 10031. We are given the C number, C node as 10031. I'm continuing from there.
Oh, you should give one more connecting now?
Yes, yes. This is you see, first one is 10, that is from plant, that mating plants to the pipe plants. That is first one. And next one is that reinforcement pad, that is on the equipment. That is 10030 and that C node is 10031. Okay. Then now we are going to model the equipment. Okay. And what is the 2438? No, OD?
Yes.
OD we have to enter here 2438. And what is the thickness? Thickness is 15.9 mm. Okay.
15.9.
Hello?
Correct.
Yes. Okay. So 15.9 mm thickness. And here is off of the OD we have to go. Minus, I think that this is this one.
Why you should go to upper level?
No, from the center line of the equipment only we will go. We have to click rigid. No, pipe also we are modeling from the center point only, not at the edge or.
Correct.
Okay, so this equipment also it will be at the center point. Okay, you see on rigid, you see, given rigid.
Okay.
If you are not giving rigid, it will look like on the equipment.
So what you should do? Rigid or
Because the what?
rigid only should do?
No, rigid only we are taking.
And then weight?
You give rigid, that is the best.
Then weight?
Weight it's not required. The weight is not required. Only because of temperature only we are going to see what is the expansion and what is the load.
So no need to, you should just do the
Right. Yes. Okay.
So then weight of the vessel
Doesn't matter. Yes. Only for air cooler, no? You know, air cooler, air cooled heat exchanger is there, no?
that yes.
Only,
we are not line.
Yeah. Only for the air cooler line, we will model the bundle weight. We used to give the weight because for that air cooler, no, that is a must. Because two headers will be there, no? One is fixed header and one is sliding header. The floating header will be there. So the vendor usually give the that displacements and also movement, that gap they usually give, axial gap, the lateral gap. So that we have to model exactly. Then only you will get the exact result. Okay. It is there, no? This air cooler modeling is there?
It is there. My project is there. Because it's a refrigeration, right? Air
Oh.
will be definitely there. Yeah, I think one of the files what I have said it's there.
It's there, huh? Just a minute. Check. ACC, yeah, air cooled condenser. Maybe this one. Oh, yes. I think. They model there now. They model the things. Just a minute. Can I call you after some 1 or 2 minutes from my home? I'm getting a call. Okay. For saddles, you have to give ambient temperature.
Yes.
Initially, okay, before starting itself, we have to fix this one, ambient temperature for this project.
Oh, where it is?
Here, here is the ambient temperature for this job.
Okay.
21.1. Okay,
That's
if it is 21.1, it's
it's
okay.
okay, right? It's normal.
Yeah, it's okay. If it is, if the project is in,
Mi-
if the site is in Kazakhstan or
But in Middle East,
Port
in
Russia,
Dubai,
in Norway. No, in Dubai and all it is okay. 21 ambient temperature is okay.
okay,
If it is in the Kazakhstan cold countries, no, the temperature will vary.
okay.
They'll give -5 or
Oh,
0 degree
really?
like that. Yeah.
Okay.
Okay, no. So and here also liberal stress allowable is there, no? You see,
Yes.
liberal stress allowable for this
Mm.
job. That should not be. You should not use that.
Okay.
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 I'll tell what is the problem in that. Okay. While seeing the final output.
Okay. Okay.
After analysis, we'll say I'll tell why we should not use
Okay.
this. Okay, this is the equipment simple model, and now temperature we have to check. For saddle, we have to give 21.1. 21.1, and T2 also same temperature 21.1. And if you go to the next node, no, it will have the same temperature. You have to change that. You see, here we have used 21.1. If you go to the next node, it will be having the same temperature, 21.1 only.
Oh, even
That,
okay.
that we have to change. I mean 200, 150,
160.
160 I didn't change.
Okay. Okay.
Okay. We'll
Then
check.
we have not changed it.
And then for the next, one more saddle is
Last
there, no?
one.
For that saddle, you have to give 21.1.
21.1.
21.1. And for the equipment, it should not use pressure. Pressure should be 0.
Okay.
Fluid density, insulation thickness, everything should be 0.
Oh.
Insulation thickness 0, and the pressure 0. Because we are calculating only the displacement. What will be the problem? Only because of thermal.
Okay.
Okay. So for that, pressure is not required, fluid density is not required, weight is not required. Okay. Like this only you have to model. This is a simple pressure vessel.
Okay.
And for columns, towers, everything will be the same procedure only. For columns, you will model this one. You see, up to here it will be same. After that, the column will be around 20. For example, if it's a top line, the top nozzle means
Okay.
up to the skirt you have to model.
Oh, okay.
Skirt, at the skirt point only you have to anchor it. There won't be any sliding saddle, no, only one.
One skirt,
fixed.
correct.
Yeah, okay. For columns it will be same procedure you have to follow.
Okay.
For heat exchanges, everything you have to follow the same procedure.
Okay.
For pumps, this modeling and all not required. Up to that junction point will be there, no? For suction and ditch, for example, I'll show you here. Okay, for example, this is suction, and this one is discharge.
Okay.
Okay, we have to model up to this point only.
Ah, okay.
Okay, no need to model full pumps and all.
Okay.
Anyway, we are going to check at this point. This is not a pressure vessel.
Correct.
Okay, this is this. We'll check the nozzle allowables at this point only.
Okay.
Not here.
Okay.
Okay. For that, this mounting is very simple. It will be very less. 200 mm like that.
Correct. Okay.
You check. You model some.
Sure, I will model one.
You will try to model.
So when we will be meeting again? Saturday.
Again, Friday.
Friday night. Okay.
Oh, Friday will be only.
Friday or Saturday?
We'll check.
We will check Friday or Saturday.
Yeah.
Okay.
Yeah.
Maybe
Okay,
Friday. This time I will be at home only.
Oh, okay, okay,
If
okay.
I go anywhere, I will tell you. We will fix. Okay.
Yeah, yeah, yeah. No issue, no issue.
Thank you very much. And
Okay, Shivakant.
okay,
How do you feel this
this
class?
is very good.
Okay,
Yeah, actually,
uh,